So today let us understand the concept related to source transformation, its rules, its application with respect to electric circuit analysis. So I am Mohan BS from Department of EEE SJBIT. Source transformation, a technique very useful for simplifying the networks or circuit which it is related to practical sources. So we are aware we have two types of practical sources. We'll see them in the upcoming slides. One is current and voltage source. So this is applicable only for practical sources and not for ideal sources. And what happens or how do we solve for ideal sources? That will be taken up shortly with respect to source shifting and source transformation. So the technique or method of transforming one form of source into another is known as source transformation. So as you can see in the below image, so we have given voltage source whereas we have a resistance in series. If the resistance is not there, it is called as ideal voltage source. Similarly, on the right hand side, we have current source and a resistance in parallel. If we have only current source alone, it's called as ideal current source. So now let us discuss here why do we have resistance in series. So practically, the voltage source, the output terminal is always lesser than its value. It is slightly lesser. So the resistance that is connected or to show its internal resistance is always having low value. So low resistance as the amount of current flows will have low voltage drop, thus the terminal will have much slightly lesser compared to your terminal voltage. Similarly, the output current that should be available to the load will be slightly lesser than the ideal condition. So the resistance should be, any guesses? So the resistance should be higher here so that all the current should not pass. If the resistance is lower for the current source here, if the resistance is lower here, then all the current will pass through this and the current available for the load will be lesser. So thus the resistance is higher, a small amount of current will flow through this and the larger amount of current will be available to the load. So now if the polarity of your voltage source is given in this way, using source transformation, how do we mark the direction of current or what is the orientation of current? So the arrow would be towards positive and the tail of the arrow would be towards negative. Thus for the voltage, as you can see, it is positive here and thus for the current you can see the arrowhead is upwards. If the orientation of voltage is as shown, then the orientation of current will also change. So thus you can see positive is at the bottom, the arrow is also going towards the bottom and negative is towards terminal A and the tail is also, you can see it is towards terminal A. So this is how one can convert voltage source to current source, vice versa current source to voltage source. So now let us see what are the equations for current and voltage in the upcoming problems. But just by application of Ohm's law, one can write the values for voltage and current. So if the given voltage and resistance is known, we can convert by Ohm's law. I is equal to, the value of I is V by R. Similarly, if we know the practical current source values, it's I and R. By Ohm's law, one can write the value of V is equal to I into R, and then the R would be in series. Right. So you can see here we have one branch with respect to practical voltage source and we have two branches with respect to practical current source. And as I said, we can represent using Ohm's law the value of V and R in terms of I and R. So I by Ohm's law we know it is V by R, right? And as you can see here, positive is towards upward, negative is bottom, and thus you can see the arrow is also going towards upwards direction and the same resistance will be in parallel to the current source. Right. So let us see the different forms of voltage representations here. Okay. So the first one is actually an voltage source. Second one, it's obvious that it's a current source. What about the rest four? The rest four are your dependent sources. Let's see one by one. So this is called as voltage dependent voltage source or voltage source depending on voltage. So how do we know the dependent is a voltage source? How do we know it depends on which parameter? So let's see. So here you can see all these rhombuses which are given. What is there inside it? Which symbol have they given? What is the orientation they have given? So all these rhombuses you can see the first two is voltage. As you can see they've given the polarity. And the rest, last two, you can see they're given orientation with respect to arrow. That represents current. So whatever is there within the rhombus is actually your sources. So the first two are voltage source, okay, and the rest two are current source. Now how do we know the dependent parameter? Okay, you can see this also indicates what is your source. So you can see it indicates as V, I and I, and that also indicates what is your source. And now how do we identify the dependent parameter? So you can see in the first case it is VC, it depends on voltage. The second case it is IC, it depends on current. The third case it depends on voltage, and the last depends on current. So the first case it is voltage source depending on voltage. So you can understand this in two ways. That is, it depends on voltage, it's a voltage source, or it's a voltage source that is depending on another voltage somewhere in the circuit. The next is current dependent voltage source, or it's an voltage source and it is depending on current. And the last but one, it is again voltage dependent current source, or in the rhombus they've given current, thus it's a current source and the dependent parameter somewhere voltage in the circuit. And the last one, in the rhombus you can see it's a current and dependent parameter is also current. So it's a current source depending on current, or dependent, or else it's a current dependent current source. So the first two are your independent sources and the rest four are your dependent sources. I repeat, the first two are your independent source. That means if I have a 12 volt battery, ideally irrespective of the circuit, it always has a potential of 12 volt. If I have a 3 ampere current source, irrespective of the drops, irrespective of in an ideal condition, irrespective of the losses, it always tries to supply 3 amperes. But whereas the rest four C, D, E and F images, they depend on some other parameters in the circuit and they change if some parameters are changed. Whereas the first two, it is constant. Irrespective of the circuit changes, it always tries to deliver the same output. So let us see a problem with respect to source transformation. So here is a circuit. They are asking us to solve for V0 and explicitly by source transformation. So what is V0 here? They have given the polarity. So V0 is actually a multimeter or a voltmeter, analog or digital, where if they keep the positive probe at the top and negative probe at the bottom, what is the drop that reads across 100 ohms? So throughout the circuit, one has to ensure that this parameter is unaltered. This should not be used for source transformation. It has to be unaltered. You have to make sure that in each step you carry with this 100 ohms. You do not alter it. So let's see how do we start. So here you can see between these two, that is here 250 volts and 25 ohms, I have marked as A and B, red and blue, right? So I can transform that into equivalent current source. How do we do that? So as you can see in the previous slides, we had one voltage source and resistance that can be connected to current source with two branches, consisting of two branches. That is one current source parallel with the resistance. So by Ohm's law we know I is equal to V by R. So V that we have used for transformation is 250 volts and R is 25, and it is like practical voltage source. Thus if I use that, the value of current would be 10, and then what should the resistance be? 25. And how should that appear for a current source? For practical current source, the resistance should be in parallel. Okay, so thus the 250 volts will become 10 amperes, and then the 25 ohms would come in parallel across A and B. Or we can also say that this one branch has now converted to two branch between the node A and B. And then how do we proceed further? And if you can see this 8 and all these branches, first, if I say the 20 ohm is first branch, 100 second, 8 amps third, 25 ohms fourth, and 10 amps fifth. So all these branches are in parallel, and one knows that in parallel we can add or subtract currents. Thus 8 amp and 10 amp can be reduced to one single independent current. Now should we add or subtract? So you can see based on the direction or orientation, one knows that we must actually subtract. right? Right. So I have done in this way, that is 10 minus 8 we get as 2 amperes, and since I'm subtracting from 10, I have retained the polarity of 10, right? Or the other way around, if you want to do the other way around, there's only two ways of subtraction, either 10 minus 8 or 8 minus 10. So if I'm subtracting from 10, I retain the polarity of 10 amperes. If I'm subtracting from 8, I retain the polarity of 8, and the magnitude being minus 2 for 8 minus 10, and the magnitude being plus 2 for 10 minus 8. I repeat, 10 minus 8, retain the polarity of 10 and the magnitude is 2. 8 minus 10, the magnitude is minus 2 and retain the polarity of 8, thus going down. So I'll be using the positive. We can also use the minus 2 amperes and try, we get the same answer. And now you can see, as I mentioned, one should not use this 100 ohms for transformation. And now how do I reduce? Now one can analyze that 25 ohms and 20 ohms are in parallel. I repeat, 25 ohms and 20 ohms are in parallel. So thus, if we solve them, we get the R equivalent for 25 and 20 as 11.11 ohms. So that means these two resistance will become one resistance, and that appears still in parallel. And the next step, convert the practical current source to practical. So here we have different ways of solving from here. Let's see one by one. So 2 amperes is the main current that will be divided. Current will be divided for the resistance 11.11 and 100 ohms. So the current that is going through 100 ohms is taken as I2. So we know by Ohm's law, V is equal to R into I. The R is I2. So by current divider, I2 is given as main current into opposite resistance divided by the sum of the resistances. So by solving this, we get the value of I2 as near to 0.2 amperes. Substituting that above for V0, we get approximately 20 volts. So let's see other way around. So if I convert this practical current source that we have, that is 2 amperes and 11.11 across AB, that is red and blue dots, I get the voltage source as 22.22, and then the resistance would be in series, that is 11.11. Now we have a single loop, so let's apply KVL. So by Ohm's law again, we know V0 is equal to R into I. Here we have taken current I in clockwise, thus I by KVL is 22.22 divided by the total resistance 11.11 plus 100. We get approximately 0.2 amperes, and then the voltage by substituting the value of current as approximately 20 volt. Now we also have third method, and for third method we do not need this equation by Ohm's law. We can directly get V0. So pause the video and analyze what could the other method be. Okay, and then you can continue. So the other method is by voltage divider, and by voltage divider we do not need the upper equation, that is we need not find current. We can directly get what is V0. So voltage divider, as we have a single loop, we can apply the voltage divider. So V0 is equal to main voltage, that is 22.22, into same resistance, that is 100, divided by the sum of the resistances, that is 11.11 plus 100. We get directly the value, that is 20 volts. Now if the question is asked in source transformation, so you can stop having that load, which is in this case 100, and you can have the circuit, the other part of the circuit, either as a practical current source or practical voltage source, and solve. So you can solve either towards the steps shown towards left or the steps shown towards right. So any one of these two should be performed. Thank you for watching the video. Please subscribe for the other videos to enrich your knowledge. Thank you.